Okay, we're going to look at a new aspect of quadratic equations under the lesson title, the quadratic formula. Okay, now we're just going to introduce this straight away. It looks quite complicated, and then we're going to talk about it. Now, the quadratic formula is given by this quite lengthy equation, which is x equals minus b, and then this plus or minus, which we'll discuss in a minute. So that's plus with a minus underneath it. We pronounce that as plus or minus. So x equals minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. So x equals minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, so that is called the quadratic formula. Okay, where x is the value or values of the roots of a quadratic equation given by ax squared plus bx plus c equals 0. This can all sound quite confusing at the minute, but let's just immediately try and bring some relevance into play here. Okay, so we've got quite a complicated looking equation. Now, why are we going to use this? Well, we're going to use this as an alternative to factorising to solve quadratic equations. Now, we've done a lot of work with solving quadratic equations by first of all factorising. For example, if I had x squared plus 9x plus 20, I would then say two numbers that multiply give 20, add together to give 9 is 5 and 4. And I would have x plus 5 equals 0 or x plus 4 equals 0. And then I would get two results, x equals minus 5 and x equals minus 4. And what that would mean then is that I've got a positive x squared concave down parabola. And there's a root at minus 5 and there's a root at minus 4. And that's what's going on there. Okay, now there is an alternative way of solving this quadratic equation, and here's the first way that we've learned, and that's through factorisation, putting things into brackets. That's a good way of doing it. But there is an alternative, which is to use this thing called the quadratic formula. Now, there could be a question asked then as to, well, if we've got this way of doing it, which we've learned, which is factorising, then what's the point of introducing something new? Well, let's have a think about a scenario in which we had the quadratic equation x squared plus 7x plus 4 equals 0, and we were asked to solve that. Okay, so let's look at this one again. Two numbers that multiply give 20, add together to give 9, 5 and 4, 5 fours, or 20 and 5 plus 4 is 9. So in this case it would be two numbers that multiply give 4, and add together to give 7. Two numbers that multiply give 4, and add together to give 7. Now the problem is there is no combination of numbers that multiply to give 4 and add together to give 7, so we're going to struggle to factorise at that point. However, this is still a quadratic equation that can definitely be solved, but this time we're going to solve one that looks like that by using the quadratic formula. And that's why the quadratic formula is handy, because if factorising proves difficult or even impossible, the quadratic formula will always do the job. So we're going to prove that the quadratic formula will do the same job as factorising by using this example here. So we've already solved this example, and we know that x squared plus 9x plus 20 equals 0 will generate two answers, and that's your two roots, two answers which are minus 5 and minus 4. What we're going to have a go at doing is using this thing called the quadratic formula to see if we get the exact same two results. So let's go ahead with that. Okay, so using the quadratic formula, Let's try that example 1, x squared plus 9x plus 20 equals 0. Now if it works, I should expect the same two results I got last time, which were -5 and -4. So let's see. Now, in that note, you should have noticed that the quadratic equation was given in that form, ax squared plus bx plus c equals 0. So that's a kind of general way of representing the quadratic equation. So if we don't know what numbers are here, and it's just generically, we just say in general then it's ax squared plus bx plus c equals 0. Okay, so in this case, let's identify what a, b and c would be. Well, these are our coefficients. The coefficients are the numbers that are in front of x squared and x and so on. You can see that a is equal to, well, what number's in front of x squared here? Well, if we can't see it, it's 1. So a is definitely 1, b is definitely 9, and c is definitely 20. So let's just note that. A equals 1, b equals 9, and c equals 20. Now let's introduce this equation. Minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, now our next step is to take this a equals 1, this b equals 9, and this c equals 20, and to put those values for a, b, and c into this equation. It looks quite complicated, but it's actually quite easy to use. You just take your time. So where I see b, I replace it with 9. Where I see a, I replace it with 1. And where I see c, I'm going to replace it with 20. Okay, so let's just take our time. So b equals 9, and I've got minus b. So b equals 9, so minus b must be minus 9. I've then got this plus or minus, and then it's the square root of b squared. So b is 9, so b squared is 9 squared minus 4ac, so that's 4 times a times c. 4 times 1 times 20, all divided by 2a, so it's 2a, that's 2 times a, which is 2 times 1. Okay, so let's keep going, and let's try and simplify that in there. So we've got minus 9 plus or minus, okay, so in here let's take our time. 9 squared, well, 9 squared, that's 81, minus 4 times 1 times 20. Well, let's just put that together, that's quite easy. 4 times 1 times 20, so 4 times 1 is 4. 4 times 20 is 80, and we've got the minus in front, so that's minus 80. All divided by 2 times 1, well that's just 2. Okay, and let's keep going. So that will be minus 9 plus or minus, well, it's the square root of 81 take away 80, so that's just 1. And that's all getting divided by 2. Now at that point I'm just going to concentrate on this plus or minus. Now what that does then is that then splits things up. So what that says is you get minus 9 plus the square root of 1, or minus 9 minus the square root of 1, all divided by 2. So it's either minus 9 plus square root of 1 over 2, or minus 9 minus square root of 1 over 2. But I suppose we could just take care of that square root of 1 just now as well. So that would be minus 9 plus or minus the square root of 1 is 1, all divided by 2. Now what this is going to do now is split up into 2 separate pieces of work. Minus 9 plus 1 over 2, or minus 9 minus 1 over 2. So it's like give me an option where it's going to split off. So at that point let's write the word split, just to denote that things are going to start to split apart. Okay, so the first one then is going to be x equals minus 9 plus 1 over 2. Minus 9 plus 1 over 2. And the second one is going to be minus 9 minus 1 over 2. Okay, so let's take our time. Minus 9 plus 1 is minus 8. And minus 8 divided by 2 is minus 4. Okay, second one, minus 9 minus 1. So what a minus 9, we're moving down 1. That's minus 10 divided by 2 is minus 5. And that gives us our two results. And what you will see is that was the two same results that we got by factorising. Okay, so what does this mean again? Well, that's doing the same job. It's telling you where your roots are. So we know that the roots for this equation are at minus 5 and minus 4. But we used a different approach to solve this time. We used this thing called the quadratic formula. Okay, let's try an example 2 then. Example 2, we're going to solve x squared plus 7x plus 12 equals 0. Now, we're going to use two approaches just to prove one more time that this quadratic formula works and it does the same job as factorising. Okay, so first of all, let's do it by factorising. Two numbers that multiply give 12, add together to give 7. Two numbers that multiply 12, add together give 7 is 3 and 4, x plus 3 bracket x plus 4 equals 0. Okay, so x plus 3 could be equal to 0 or x plus 4 could be equal to 0. Okay, bring them over, change their sign, and I get x equals minus 3 and x equals minus 4, which means this time I've got a parabola concave down and roots at minus 4 and minus 3, and let's just see if we get the same result by using the quadratic formula. Okay, so remember that we need to think about this equation as being in the form ax squared plus bx plus c is equal to 0, and we're going to identify a, b and c. So there's a, it's 1, there's b, it's 7, and there's c, it's 12. A is 1, b is 7, and c is 12. Now hopefully when we solve this, we will get minus 3 and minus 4. So let's just quote this quadratic formula again. This will be given to you in the examination formula sheet. And it's minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, so let's remember that where I see a, I'm going to replace it with 1. Where I see b, I'm going to replace it with 7. Where I see c, I'm going to replace it with 12. Okay, so x equals minus b, so b equals 7, minus b must be minus 7, plus or minus the square root of b squared, that's b equals 7, so b squared is 7 squared, minus 4 times a times c, 4 times a times c, which is 4 times 1 times 12. All divided by 2 times a, and that is 2 times 1. Okay, let's tidy it up. Minus 7 plus or minus the square root of, okay, 7 squared, 49, minus 4 times 1 times 12. Well, 4 times 1 is 4, and times that by 12, and that's 48, and there's a minus before it. All divided by 2 times 1, which is 2. Okay, let's keep going and taking our time. X equals minus 7 plus or minus the square root of 49, take away 48 is 1 over 2. And then square root of 1, that's easy, that's just 1. So now we've got x equals minus 7 plus or minus 1 over 2. Minus 7 plus or minus 1 over 2, so that means we've got minus 7 plus 1 over 2, or minus 7 minus 1 over 2. So let's split it up to that effect for two separate bits of working. Okay, so first bit over here is going to be x equals minus 7 plus 1 over 2. And over here, minus 7 minus 1 over 2. Okay, so minus 7 plus 1 is minus 6. Minus 6 divided by 2 is minus 3. And minus 7 minus 1 is minus 8. And minus 8 over 2 is minus 4. And again, that proved the point again. That was the same two results that we got by solving through factorisation. Quick reminder, what does that mean? We've just calculated the roots for the parabola to be minus 4 and minus 3, and that's what the quadratic formula does.